we are going to see the problem of beams. There are two beams, means one is fixed support, another one roller support, and this is the roller support. Okay, our aim is to find the deflection of the beam at midpoint. At midpoint means the beam will deflect like this, and by FEM method we have to find the deflection of beam at midpoint. Okay, first we are going to separate the beam into two parts, the part 1 and part 2. Okay, this we will call it as a element 1 and element 2. Then each having 5 meter length. Okay, in this one we have to calculate the stiffness matrix of each element, means force is equals to stiffness means K into deflection. This one we have to use this one formula. Okay, but in the stiffness matrix we have to calculate the K matrix. That one we have to take the value of E, Young's modulus. We should take each and every value in case of beam in the SI unit. SI unit should be prepared in case of beam. Okay, E will be 2110 GPa, gigapascal. This will be converted to MPa. MPa means Newton per mm square, and then Newton per mm square is transferred to Newton per meter square by multiplying, means this mm square is transferred to meter square, and this will come the Young's modulus into 110 into 10 to the power 9 Newton per meter square. Okay, then second term in the stiffness matrix we have to calculate the moment of inertia. This is I. In the problem I is given 5 into 10 to the power 6 mm raised to 4. Then we have to transfer it to the meter raised to 4. Therefore we are going to multiply it by 10 to the power minus 3 and raised to 4, means this will be converted to meter raised to 4. Means final value of moment of inertia I is equals to 5 into 10 to the power minus 6 meter raised to 4. Then L, the given length of beam, we are considering the element 1 and the length of element 1 is 5 meter. Okay, therefore the L1 is 5 meter. Then L cube will be 125. Putting the formula, in the formula EI by L cube is equals to 2110 into 10 to the power 9 into 5. This will be 8.4 into 10 to the power 3. Okay, then stiffness matrix is equals to 12 6 Le minus 12 6 Le. This will be reflected in third row, but in inverse sign, minus 12. This one is plus 12, this one is minus 12. This one is plus 6 Le, this one is minus 6 Le. This one is minus 12, this one is plus 12, and this one is plus 6 Le. This will be minus 6 Le. Okay, then second row is 6 Le, 4 Le square, 6 Le, minus 6 Le, and 2 Le square. 6 Le is reflected as it is 6 Le, minus 6 Le is reflected as it is minus 6 Le. 4 Le square will be replaced in this place, and 2 Le square is replaced in this place. Okay, this is the simulation for remembering the formula. Then we are going to find the K2. We have find the K1 value of K1. Then we must find the value of K2. Means K1 is the elemental stiffness matrix for 1 and K2 will be elemental stiffness matrix for this element. Okay, then in this element the Young's modulus will be same E, then moment of inertia I will be same, and the length of beam is also same, 5 meter. Okay, therefore we are going to take K1 is equals to K2. Therefore K1 is equals to K2, means this will be our K1 value by putting the 12 6 Le, means 6 into 5 will be 30. Okay, 30 minus 12 minus 30, this will be value of K1. Okay, and K1 is equals to K2. Then we are going to form a global stiffness matrix. Global stiffness matrix will be adding K1 and K2. Okay, here we have the two elements. Each node has means three nodes. Here is one node, this one is second, and this one is third. Each node has 2 degree of freedom. This one has 2 degree of freedom, this node has 2 degree of freedom, and this has 2 degree of freedom. We call it as Q1, Q2, Q3, Q4, and Q5, Q6. Means in the first element there are 4 degree of freedom. Okay, therefore the K1 is 4 by 4 matrix. Okay, and in second element there are also means 2 and 2 4 degree of freedom. Therefore K2 matrix will be 4 by 4 matrix. But we are going to take whole global matrix of this one. So the global matrix will be 6 by 6 because there are 3 degree means 3 nodes and each node carries 2 degree of freedom. 2 plus 2 plus 2, 6 by 6 will be global stiffness matrix. Okay, this will be arrangement. In the first K1 will be placed, this will be placed for K1, and this is the place for K2. Okay, and remaining means addition of the two elements takes place in 4 digits, means in that 4 places. Okay, then we are going to see. Okay, the friends, we have calculated the K equivalent matrix. Okay, this arrangement K1 will be in this place and K2 will be in this place. But we are going to calculate, means we have calculated this matrix. This will be our K matrix, K equivalent matrix. 1 2 3 4 5 6, and rows will be columns will be 1 2 3 4. 1 2 3 means this will 1 2 3 here 4 5 and 6. Okay, this will be K equivalent matrix. Then we have to calculate in our equation K into Q is equals